Hello everyone, my name is Kamal Timsina and I am here to present my research on the topic of co-inoculation with avascular mycorrhizal fungi and root lesion nematode on the diverse Mugwort varieties. I am a student at UNASQ, currently pursuing my master's degree on agriculture, and my research is supervised by Dr. Ravi Kajwal. Thank you once again for being here, and without further ado, let's dive into the fantastic world of co-inoculation with AMF, root lesion nematode on diverse Mugwort varieties. Thank you. So, talking about the agenda for this presentation, I will start with the introduction, which will be followed by problem and the significance of the research, aims, expected outcome, methodology, research design, data collection, result, discussion, and further recommendation and acknowledgement. Sorry, and I will give lastly some references as well. Now, talking about the introduction of the Mugwort. Mugwort are important leguminous crops that are cultivated in the various regions across the world, including South and North America, Australia, Central Africa, and different parts of China. With a worldwide cultivation area exceeding 6 million hectares, Mugwort hold significant agricultural importance. One of the key reasons for their cultivation is a high protein content found in their grain, making them valuable for both human and animal consumption. Mugwort are typically grown as annual crop in warm season and have a relatively shorter growth cycle of 75 to 90 days. In fact, mugwort contribute 8.5 of the world's pulse production. Furthermore, moving forward to the root lesion nematode Pithornei, they are a microscopic worm-like organism measuring less than 1 millimeter in length as a migratory endoparasite. They reside in the soil and plant roots where they feed on the root cortex cells. The presence of pith thornei can cause significant damage to the mugwort plants, leading to observable symptoms such as patchy or webbed appearance, increased susceptibility to the wilting and yellowing, and sign of nitrogen or water deficient. Affected plant may exhibit weakened root system, making them easily plucked out from the ground. Now moving forward and talking about avascular mycorrhizal fungi, which establish beneficial symbiotic relationship with the root of approximately 80% of plant species. The fungi play a vital role in enhancing crop yield and promote plant growth. They are often referred as a biofertilizer or bioprotectant due to their ability to improve the nutrition uptake. Now moving forward, we'll talk about the problem and the importance of this research. So the increasing population and the projected population of over 9 billion by 2050, it is crucial to address the challenges of the global food production. According to the study, the global food production needs to rise by 70% by 2050 to meet the growing population demand. One of the significant biotic limitations affecting the productivity of mugwort is root lesion nematode, especially Pithornei. This nematode causes substantial yield loss and can have a detrimental impact on the food production. It is estimated that worldwide food production experiences an annual loss of 12.3% due to the nematode inspection. By understanding the dynamics between AMF nematode, the researchers can develop sustainable agricultural practices that lower yield loss and promote more efficient mugwort production. So moving forward with the aim of this research, in this research we aim to analyze the impact of co-inoculation with AMF and Pithornei on Pithornei population densities. By conducting a systematic experiment, we'll investigate how the presence of AMF influences the population dynamics of Pithornei in mugwort plants. Now moving forward, we'll talk about the expected outcome of this experiment. Different mugwort varieties may respond differently to the co-inoculation. Some varieties might show a decrease in Pithornei population densities while co-inoculation with AMF, while others may not show noticeable effect. And the interaction between AMF colonization and Pithornei population size can vary across different mugwort varieties. Now moving forward and talking about the research design, the first column pods in the first strip were inoculated with Pithornei and AMF together with several types of mugwort varieties, as shown in the table below. while the second column pods in the first strip were just inoculated with P. thornei and not with AMF. The third column pod are similarly not inoculated with either of those, or the last pod of the first rep are just inoculated with AMF. The remaining four replication of the inoculation procedure are completed using a similar procedure but in a randomized manner. The experiment was tested on the 10 different Mung varieties, which are listed in the table. The experiment will consist of the 5 replication, with each replication consisting of the 40 pods. Now, talking about the method of planting, in this class of setup, the experiment was set up on the two benches to accommodate the required number of the pods. Each pot equipped with a self-regulating bottom watering system to ensure constant and uniform moisture level throughout the experiment. This system will distribute the same amount of moisture to all the pots. Now, talking about the method of planting, soil moisture calculation was done so that each pot get 3300 gram dry wet soil. Pithornia were harvested from the 2022 OPC culture using white tray method. Now moving forward with the data collection process. For this, the Mung plant were grown for 10 weeks. Plant growth parameter including plant height, plant biomass, pods number, as well as AMF colonization and Pithornia population density was recorded as a part of data collection. The data collection process involves several steps to assess the growth and maturity of mung bean plants and the impact of AMF and Pithornia treatment. Nematode extraction was done using a white head tray method, and the extracted nematode were counted using the Petri slide under the microscope. AMF colonization was quantified by washing a subsample of the soil and the root mixes over a sieve, cutting the root into small pieces, and stain them with the tryptophan, blue, and lactoglycerol. The stained root were examined under the microscope using a grid intersection method to determine the degree of AMF colonization. Now moving forward with the data analysis and the result section. The data analysis was done using the R Studio. The nematode count data was transferred using a natural logarithm transformation. AMF colonization was also normalized using R-sine transformation. An analysis of the variation ANOVA was conducted using the Agricola package in RStudio. So we can see like two graphs in this picture, and this is the result of our experiment. The following result was obtained as a part of our experiment. When we look at the left hand side graph, we can see that there were significant main effect between the AMF and minus AMF treatment. No colonization was observed in the mung bean varieties that were not treated with AMF. The mung bean treated with both Pithornia AMF had a great level of AMF colonization, that is 0.54. Then seen in the mung bean treated with only AMF, that is only 0.46. However, this difference was not significant. Now looking at the graph of right hand side, we can see that there were no significant difference in the AMF colonization with different varieties of the mung bean when they were inoculated with either Pithornia or not. The figure shows that the variety called ZAU had the highest level of colonization by AMF. This means that these varieties interact well with the AMF when either Pithornia was present or not, and could potentially benefit more from its presence. On the other hand, the variety called green diamond had the lowest level of colonization. This could be since this variety did not germinate well in the glasshouse. However, it is important to note that the difference in the AMF colonization between the varieties were significant. This means that all the varieties somehow shows the similar in their interaction with AMF. So moving forward, we can see from this graph, although there were no significant difference between the interaction of genotype AMF and Pithornia inoculation, All the Mung varieties show greater AMF colonization in presence of P. thornei as compared with the treatment without P. thornei inoculation. The variety AUST RC324277 variety treated with only AMF at the lowest level of AMF colonization, that is 0.34, whereas the ZAU variety treated with both PT and AMF had the highest level of AMF colonization, that is 0.59. Now moving forward with the results section, we can see in the graph like p-thornei count. So on the left hand side graph, there was significant main effect between the PT and minus PT and plus PT treatment, but no significant difference in PT among plus PT minus AMF and plus PT plus AMF treatment. The mugwort treated with plus PT and minus AMF and plus PT plus AMF showed transfer PT value of 9.12 and 8.80 respectively. It is showing a valuable reaction to PT count as they were higher in treatment not inoculated with AMF, that is 9.12, compared to the treatment co-inoculated with AMF 8.81 only. So moving forward, seeing at the left right hand side graph, we can see that there were no significant difference in p-thornei count among the different varieties of mugwort. So you can see the variety of mugwort in the graph, and there were no significant difference as the graph labels the same. So further moving on the p-thornei count, we can see the graph showing like different varieties and the different treatment. So the results show that although there were no significant difference within the genotype between plus PT plus AMF and plus PT minus AMF treatment, all the mugwort varieties except for AZZ324812 showed the general trend of decreasing the number of p-thornei when plants were inoculated with AMF. Now, moving forward in the results section, you can see the first picture without any plant shows the green diamond variety that were not germinated at the time of harvesting as well. The below two pictures shows the ZAU variety with 4 treatment minus PT minus AMF, plus PT minus AMF, minus PT plus AMF, and plus PT plus AMF at the time of early harvest, showing no significant difference in plant height and development within different replication. For this experiment, mugwort initial growing period was supposed to be 12 weeks. During the period of the plant will have enough time to reach full maturity, allowing an in-depth analysis of the effect of nematode and AMF on the growth and yield of the plant. But due to the unexpected circumstances, caused an early harvest of the mugwort plant at 10 weeks, including a leak in the glasshouse where the plant were grown. The unexpected incident probably had an impact on the plant growth and development, which in turn had an impact on our experiment outcome. The plant were still in their growth period and had not yet reached maturity, as shown in the early harvest picture over here. As a result, it is possible that the impact of the nematode and AMF on the plant were not completely observed. So, moving forward with the future prospect or future recommendation of this research involves several potential improvements and expansion of the current methodology. Firstly, the increasing the number of replication from 5 to 6 will provide a larger dataset, which could lead to more accurate and reliable results. More replication can help to reduce the impact of the outliner and the random variation, thereby increasing appreciation of the experiment. Secondly, expanding the number of mugwort variety will show more comprehensive understanding of the effect of AMF and PT on the different mugwort varieties. Different varieties may respond differently to this inoculation, and understanding this difference could be crucial for the optimizing the mugwort cultivation. Thirdly, extending the growth period of the mugwort plant to 12 weeks could provide more insight into the long-term effect of AMF and Pithonia inoculation. The current growth period may not be sufficient to fully observe the effect of this treatment, especially for the slower growing varieties or those with a delayed response. The life cycle of the Pithonia nematode is also under ideal condition. It's like 6 weeks. Proper growth and development of the nematode can be seen with it increasing the growth period of the mug bean. Broadening the area of the research, including the response of AMF and Pithonia to the yield, biomass, plant height, and the nutrition could provide more result which can view the effect of this treatment. Biomass and the plant height are important indicator of the plant health and growth, which directly related to the yield of the plant. So considering this factor is a part of the research will be beneficial for the sustainable agriculture practice as well. So moving forward with the conclusion of this experiment, in conclusion, we can say that there were no significant difference between the interaction of genotype, AMF, and Pithonia inoculation, which was conducted in a glasshouse experiment on the different mung bean varieties. All the varieties of mung bean saw colonization by AMF when Pithonia was present compared to the treatment without Pithonia. Inoculation resulting the presence of Pithonia so somehow promote or enhance the colonization of AMF on the plant root. Furthermore, the study also found that all the mung bean varieties except AGG324812 generally showed a decrease in the number of Pithonia when the plant were inoculated with AMF. The presence of AMF has a suppressive effect on Pithonia population in the most of the mung bean varieties. The objective of the study was to find out how of these 10 varieties of the mung bean will respond in the co-inoculation with AMF and Pithonia. Due to the unforeseen circumstances that occurs in the glasshouse of the experiment was forced to early harvest, which probably influenced the result. So talking more about the conclusion, the ability of the mung bean plant to establish colonization with AMF fungi have an effect when inoculation with Pithonia, but this effect is not different. This suggests that the presence of Pithonia play a crucial role in AMF colonization in mung bean, potentially enhancing their growth. However, this effect of this interaction on the growth and development of the plant have not been fully observed due to the early harvest. For more accurate and predictable results, further studies should consider extending the growth period and increasing the number of replications. So here are some of the reference for this study. I have like listed some of the reference for this one. Now moving forward with the acknowledgement, first and foremost, I want to sincerely thank Dr. Ravika Chwat, my supervisor, for her constant encouragement and support during my research project. In addition to my supervisor, I'd also like to thank Ms. Bijita Adhikari, whose guidance and encouragement have been a constant source of support throughout my research journey. In addition to that, I would also like to thank Mr. Prashant Giri, Ms. Elina Karki, Mr. Bigyan Bhandari, Ms. Subeksha Subedi, and Mr. Vishal Bhandari from University of Southern Queensland for their thoughtful recommendation and guidance. I am extremely thankful for having an opportunity to collaborate with such a fantastic group of people. I'd also like to thank all the members of UniSQ Center of Crop Health for their continuous support. Lastly, I'd also like to thank my family members for their continuous support and love throughout this journey. So at the end, I'd just like to thank you to everyone to see this presentation. So if you have any question or queries, you can just comment down or post in the forum. I'll be able to answer them in short. Thank you.